Hello everyone and welcome. Today we are going to be reviewing the algebra, geometry, and trigonometry used in physics, at least in the high school physics. The objectives for today are to be able to solve problems algebraically, to use geometric relationships, and to identify SOHCAHTOA relationships. For the algebra, the greatest thing is to remember the order of operation, which can be remembered by PEMDAS, parentheses, then exponents, then multiplication, then division, then addition, then subtraction. That's the order these particular operations need to be performed in. Here's an example problem. We want to solve for VI, and we have 20 meters per second, and that quantity is squared, and that's equal to VI squared plus 2 times 10 meters per second squared times 4 meters. And if you notice, there are a couple of things that you can see. First, this squared and this squared and this squared are a little bit different. This squared is right, it multiplies just the VI squared. It just multiplies the VI by itself. This squared is only on the second, right here, only on the second. And this squared is outside of the 20 meters per second, so it squares that whole quantity. All right, so then we just want to simplify terms. And by the way, the VI right here, the subscript I just kind of differentiates that V from other V's. So the I goes with the V. It doesn't mean anything else to you at this moment. So to simplify, we can say 2 times 10 is 20 meters per second squared. And then we multiply that by 4 meters. And then we can say 20 times 4 is 80 meters squared, because we have meters times meters, so that becomes meters squared, divided by seconds squared. That's plus VI squared. And then that's equal to 400, because 20 times 20 is 400. And that's also meters squared per second squared. And then we can move the 80 meters squared per second squared over to the other side just by subtracting. So because it's meters squared per second squared, it's the same thing. So you can think of it as they're both kind of they're both apples. So you can subtract apples from each other. So 400 apples minus 80 apples would be 320 apples. So now we can put it back into meters squared per second squared. So then it's 320 meters squared per second squared. And that's equal to VI squared. And I'm going to write that like this: 20 meters squared per second squared is equal to VI squared. And then we just take the square root so that we can get it by itself. And that is going to get us 17.89 meters per second, because if you square root a meter squared, it becomes meters, and square root the second squared, it becomes seconds. And that is our answer with units, and that's what we're looking for. So then the next thing is going to be some geometry review. And this is actually on your reference table. It says that the area of a rectangle is base times height. The area of a triangle is 1/2 base times height, because there are 2 triangles in one rectangle. And then the area of a circle is pi r squared, where r is the radius. And then the circumference of a circle is 2 pi r, where r is the radius as well. So here is an example problem of the triangle. The bottom can be the base. And I'm going to put some units in just so that you can see what happens with them. And then this here is the height. And remember, the area of a triangle is 1/2 base times height. So then we're looking at the area, and that's 5 meters times 12 meters, and we're going to take half of whatever that is. And so 5 times 12 is 60 meters squared, and multiply that by 1/2. And that is equal to 30 meters squared. And that's equal to, and that's the area, and that is what we're looking for. So we box it in. So then the next example is one of a circle, which people sometimes have trouble with because they look at this whole thing and assume it's the radius, but it's not. The radius is half of that. So the radius is 2 meters. So then the area of a circle is just pi r squared. And if we plug that in, it's going to be equal to pi, and pi is a function on your calculator. It's just a button and you can press it. And then 2 meters, and that quantity is squared. And we are going to get 12.56 meters squared. And that is our answer. Okay. And then the next thing is trigonometry. And the thing with trigonometry is you may not have had it yet before coming to this class. And if you haven't, you will be learning it this year in, in pre-calc or trig or whatever you have. And it's just a bunch of ratios of triangles. And these are right triangles. So they must have a 90-degree angle in them. That's what that symbol there with the box means. And all of these things apply to right triangles. So anyway, there are 3 different ratios. Actually, there's more than that, but these are the ones that we'll use in this class. And it's the sine of theta, and theta is the angle that we're looking at. In this case, the angle is here. Now, the angle could also be here, but it just changes what angles we're talking about. So if we were looking at this angle here, then this would be the opposite. And this would be the adjacent, because for this angle, this side is opposite of this angle, and this side is adjacent or next to this angle. So it just depends on which angle you're talking about, and it's going to depend on what they need in the problem. It's not always going to be the same angle that we're talking about. Anyway, we have the sine of theta is equal to the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent. And we do also use Pythagorean's theorem, which is c squared equals a squared plus b squared. So again, you can only use these with right triangles, and the hypotenuse of a right triangle is always the longest side. It's also the one that's opposite of the 90-degree angle. So here is an example problem, and we want to find the hypotenuse and side B of the following triangle. So we want the hypotenuse and side B. So if we find the hypotenuse, we can start there. So to do that, we say this is the angle we have. It's some angle. We know we're going to need a ratio. So then it's the opposite. Okay, so opposite. And then we have C, that's the other one we need. That's going to be the hypotenuse because it's the longest side and it's the one that's opposite of the 90-degree angle. So that means we need to use sine because it's opposite over hypotenuse. So then to get this, we can plug in numbers. So sine of 60 is equal to 20 over C. And then we just move C to the other side so it's at the top so we can get to it. And I'm just going to erase it so that, so that we can save room. Okay. And then we want to divide by that sine 60. So then we have 20 divided by sine 60, and we can plug that into our calculator. and that is 23.25. So then we say that C is 23.25, and usually there are units on here, but we're skipping those for right now. But if we said that this was meters, then this would be meters as well. But anyway, so then we can look for B, and we can actually use Pythagorean's theorem to get that. So it's C squared equals A squared plus B squared. We need B squared, so we're going to solve for that one. We can move A squared to the other side. So it's C squared minus A squared is equal to B squared. And see, and notice I'm working just with the letters here, with the variables. I'm not working with numbers, but you can work with the numbers as well. I will typically work with the variables because as we go through the physics course, it becomes more important to use the variables because there are some questions that come up as to how things are related, and that's the easiest way to see it. But we'll talk more about that as we go. So then we have 23.25 squared minus 20 squared. And then we want to put that into our calculator to see what we get. So the squared value is going to be, so B squared is going to be 140.6976. I'm just going to say 0.697. So then it should be 140 point. So then we just want to take the square root of both sides, and it becomes 11.86. And this is our answer for B. And C was 23.25. Okay. Then our last example is to find the unknown angles in the following triangle. So we're looking for the angle B and angle A here and here for A, but we're going to start with angle B, and it's opposite over adjacent, so it's tangent. So tangent of theta is equal to opposite over adjacent, so we can plug in, and it is still tangent of theta equals 4 inches divided by 7 inches. And to get the theta by itself, it's inverse tangent times inverse tangent. Okay, and we can put that into the calculator, and we get, 29.74. So theta equals 29.74 degrees. And this is angle B. And then to get angle A, it's just going to be, we just have to remember that there are 180 degrees in a triangle. So we say 180 minus 29.74. Um, and that's 150.26. And that's all I have for you today. Thank you.